Yeah, good afternoon. So last class we have discussed about what is the binary adder and what is 4-bit binary adder and subtractor. So I'll recollect one more time for this topic. So the binary adder means we know that how to add two binary numbers, and we know that we have some carry bit is there, right? This is the binary adder. We know that if you apply the addition operation these two, you'll get this one. After end of this addition, we'll get 1, right? If it is 1, it represents a negative sign. If it is 0, it is represents a positive sign, right? This is about a binary adder, and this is about binary adder. We are taking three inputs. We have four binary adders are there. Full adders are there. One, two, three, four. So along with carry, we have three bits are inputs to the full adder. Once you apply full adder, we will get one sum and carry. This carry is forward to the next full adder. Similarly, we are doing all these operations up to last full adder. At the end of the last full adder, so it gives the sum and the carry. If it is 1, it is negative sign. It is 0. Okay, so normal number. Okay, this is about a full 4-bit binary adder. The binary subtractor is there. Add and subtractor. Subtractor, we know that R3. What is the replacement operator? R1 minus R2. So for this purpose, R3 reverse arrow R1 minus R2. This is for reading purpose. When you are operating the some micro operations on this R3 replacement R1 minus R2, this can be replaced by using the 2's complement of the second operand is added to the first number, and the sum of these two is replaced in R3 register. This is about the subtract micro operation, right? So here, if you take this is the 4-bit binary adder and subtractor. Okay, so we have a and B inputs are there. So one more input is there, that is a carry input. So we know that the full adder taking three inputs and it gives one sum and one carry. So one sum and one carry. Here in 4-bit binary subtractor, we are using one input from A naught and another input from B naught. But here in B naught, we are taking one XOR gate, right? One XOR gate, right? So here, if you take M, this is called as mode bit. If you take 0, this 0 is sent to this B naught. So it is acting as a input of the B naught, right? If you give 0 to the OR gate, XOR gate, 0, if it is 0, 0, 0, right? 0, right? That is so first bit. If you give, so M equal to 1, it takes 1, 1 and bit is 0, 1, 0. It gives, right, complement of b naught 1, like that. We know that all these operations, so b1 and b2 and b3, so this is the binary subtractor. So how to represent that binary subtractor? If m equal to 1, a plus b bar plus 1, which means the b bar means 1's complement. If you add 1, this is 2's complement. So the 2's complement addition with the first one, and these two are summed and stored into the some other register. That is about subtractor, right? So here, today's class, we need to discuss about binary incrementer. Binary incrementer. We know that binary incrementer. We What is the binary increment? We have if you increment. So see, so what is the increment? Increment operator. We know that a plus plus in C language, a equal to a plus 1 will give a equal to a plus 1, right? In C language, a equal to a plus 1. Like that, if you give b minus minus, we know that b equal to b minus 1, right? So this is about binary subtractor topic, right? So in simple C language, the increment operator is that a plus plus, so we can represent a equal to a plus 1, right? So this is for our better understanding purpose. In binary incrementer, so if you take R1 equal to R2 plus 1, this is the binary increment. So for suppose one, if you take this one, so consider R1, this is the carry, this is the sum. If you take R1 1101, this is the register R1 information, right? If you add 1, if you add 1, so 110, you know that 1 is carry, 101, sum of these two, 10 is 1, so the carry is, so the carry is 0, that is forward to the second bit. 01, 01 means 1, right? This 1 is replaced here, again 0 is forward to the next binary digit. 0 1 1, there is no carry, right? If you consider this one here, the carry is 0, right? So here if you observe first, while performing this addition operation, 1 1, we are taking two inputs only, we are taking two inputs. So the one of the R1 register extra, we are adding 1, we are taking two inputs, so that while performing increment, binary increment, we are taking off adder. For half adder, we are taking inputs, two inputs. So see, so that is this is the diagram for 4-bit binary incrementer. 4-bit binary incrementer. If you say this is HA means all these are off adders. Whereas in the case of full adders, if you observe here, one input from B naught, one input from A naught, one input from carry, that is called as C naught. Okay. So by default, the definition of the what is that full adder is, it takes three inputs, so it gives one sum and one carry. Whereas in the case of off adder, it takes two inputs and it gives one sum and one carry. One sum and one carry. For example, so here here a naught, a1, a2, a3, this is the what we have given R1 information, 1101, 1101, right? So we are adding one more 1 to the this binary digit, we are adding 1, that is acting as a y. Okay, so x, the x, this x input is taking from a naught, this x input is taking from a1, this one is taking from a2, this one is taking from a3. Okay, that is one input. So the next second input, y. Y. For the first half adder, the y, already we are adding 1 first time, that is acting as a first input. Okay, once you perform the operation with this half adder, it gives one sum and one carry. Whenever the carry is released from the first half adder, it is acting to the second adder input, second half adder input. Okay, so for suppose 1 1 0, sum is 0, so what is the carry? 1. The 1 is forward to second of adder. Again, this 1 is acting as input to the second of adder. Again, these two are sum. 1 0 1 0. It gives 1. Sum is 1. Okay. So next carry is 1. What is that? Carry is 0. Again, this carry is sent to y. Second of adder. Next again, sum of these two. So 0. See, the second 1 0 1 0. So 1 0 means it gives sum is 1, the carry is forward to 0. Okay, so and again 1 0 we are taking 1 0, so 1 0 means the sum is 1, the carry is 0. The carry is 0. This is about 4-bit binary increment. This is about 4-bit binary. So did you understand this one? Yes or no? 4-bit binary increment. Hello?
Yes, sir.
Okay, did you understand? So one more time I repeat this one. I am taking R1 register information 1101. If you add 1 to this R1 register, simply you are doing 1. If it is 1 1, we are getting some 0. Again the 1 is forward to the next register, next binary digit 1 0, again 1, and 1 0 like this we are performing. So here why we are taking off adder means initially we are taking 2 inputs so that we are taking off adder, whereas in the case of full adder we are taking 3 inputs so that one extra is previously we are taking carry. So here if you perform this operation to here, all these are a naught bits, the second bit the the initial taking extra one bit is sum to the existing binary number, and these two are applying addition, and sum gives to the s naught and carries forward to the next off header. This is similarly we are doing all these three off headers, you'll get extra carry that carries forward to the next off headers. This is about 4-bit binary incrementer. This is about 4-bit binary incrementer. Now now we will see what is the arithmetic circuit. What is the arithmetic circuit for this for performing all these 7 operations? What is the 7 operations? We know that increment operators are there, addition is there, subtract is there, and complement is there. What is that different types of arithmetic operations are there. We have around 7 operators are there, 7 micro operations are there. Okay, 7 micro operations are there. Here, the arithmetic micro operation can be implemented in one composite arithmetic circuit. So next we are taking one circuit. By using that circuit, we can perform all these 7 arithmetic operations. The basic component of an arithmetic circuit is parallel adder. Okay, so how we are taking that adder, we will see. By controlling the data inputs to the adder, when we are applying some inputs, S naught and selection inputs to the adder, it is possible to obtain different types of arithmetic operations. How it is performing different types of arithmetic operations by using different types of input selections, we can see later, right? The output of the binary adder is calculated from the arithmetic sum, which means that D equal to A plus Y plus C in, right? So here, this is the one input, this is another input, this is the carry. This is the carry. How it is performing, what is the sum D equal to A plus Y plus C in, we can see the next slide, right? So here here see, if you see this one, if you see this one, we cannot understand directly. So this is by seeing this one, what you have understand. So here they are using fully 4 fully adders, 4 multiplexers are there. Okay, so if you know basics, this is what is the representation of this symbol? Do you know what is this symbol?
Not gate.
Not
Not
gate.
get.
What is that? Not gate. Not gate means if you give input to the 0, what is the output? If you give input,
Complement of input.
complement of that
Input.
input, right? See, if you give 0, it gives 1. If you
One.
give 1, if you give 1, it gives 0. That is the meaning of complement. What is that? Not gate, right? So we know that by seeing this 4-bit arithmetic circuit, we can understand we have 4 types of full adders are there, 4 multiplexers are there. Along with that, 1, 2, 3, 4, 5 not gates are there. 5 not gates are there. Remaining, we don't know. These are all inputs. We know that these are all selection inputs, and some carry is there. Selection inputs are 0, S1, and the output is it gives a C out. This is the carry. Okay, so when you apply input to this, it takes it fully after taking the input from the multiplexer, it gives the output D naught. So by seeing this, we can understand like this. So in detail, I'll draw the circuit by seeing that we can understand easily, right? So I'll try my level best. Otherwise, already I have written in the notes. So I took some pic. So I'll display that one and explain, right? So the next, okay. So what you have to explain 4-bit arithmetic circuit. So what is the need of a 4-bit arithmetic circuit? With the help of the circuit, we can perform all 7 micro operations. All 7 micro operations. We know that we have seen what is we have seen in that we are using 4 fully adders are there, 4 multiplexers are there. So around 5 NOT gates are we are using, right? So the first see, so this is one multi this one fully adder, and the second one is this is second fully adder, this is next fully adder. We are taking four fully adders. This is another full adder, four fully adders. Okay. So next we are taking four multiplexers. One is this is one multiplexer. This is another multiplexer. This is another multiplexer. This is another multiplexer. We are taking four multiplexers. So this is 4 by 1. I am taking 4 by 1 multiplexer. This is 4 by 1 multiplexer. 4 by 1 multiplexer. 4 by 1 multiplexer. Okay. So which means that 4 by 1 multiplexer means, oh, can you tell me what is 4 by 1 multiplexer? What is the meaning of 4? What is the meaning of 1? What is the
Four
meaning
inputs,
of?
Four inputs,
one
one
out.
output.
We are giving four inputs to the multiplexer. We'll get one output. We'll get one output, right? So if you see here, so by default we know that the full adder accepting three inputs, it gives one carry and one sum. Okay, one carry and one sum, right? We are taking x naught, y naught, and carry c naught. So sum of these three, it gives one carry, one sum, and again one carry and one sum. Similarly, so we have to draw, this is x1, y1. So this carry is forward to the next this next one, so that we are using, so here x1 c1, again we are taking c1 c2, next y x2 y2 c2 and c3. This is d1, this is d3, this is d0, d1, d2, this is d2, this is d3. Okay, so four multiplexers, so four fully adders are there. Now how to select so inputs from so from multiplexer and multiplexer to full adder, multiplexer to full adder. So once we draw this one, we'll explain all these things. So we are taking one operation carry input C in. C in is directly draw to this one. Again we have one inputs are two, 1 and 0. This is selection inputs. So what are the 4-bit multiplexer? 0, 1, 2, 3. Again each multiplexer having selection input 0, 1, 1 and 0, 0, 1, 2, 3, 1, 0, 0, 1, 2, 3, and 1, 0, 0, 1, 2, 3 inputs there. Okay, so this is about input multiplexers. So first we have to take so here the x naught, x1, x2, and x3. This is x3. So x3 c3 and y3 c4. This is the final output. Final output. C out, or we can represent C out. Okay. So this is the first input to the full adder. Next, how it is x naught? How it is x naught? By taking a naught, a1, a2, a3. We have to connect this one a naught, a naught. This is a naught. So what about this one? This is a1. Next a2, A3. Okay, so one input accepted, A0, A1, A2. So one more thing is why not. So how it is why not? So how it is selected? So here, so before that we have to use two selection lines S1 and S0 is there. So G10, 10, 10, 10. So these are all related to selection lines. So if you observe here, you can draw like this. This is belongs to, so 0. We can draw like this. Okay, this one, this one, 10 is there. This is touching to this one, connect this one, and connect to this one. Okay. Next, what about S naught? S naught is there. The S naught is connected to S naught. This is selection line 0. This is selection line 0. This is one more selection line 0. This means this is selection line 0. So why I am drawing? While you are drawing in exams, how to, what is the approach to draw this one? Then you can understand it. That's why. Otherwise, I'll take already written that pic is there, already drawn pic is there. I'll display in front of you. I'll explain that one. So by seeing this drawing process, so we can understand easily. We can draw in the exam. Okay. So this is about selection lines and 10. Okay. So next, so how to select this 0, 1, or 2, 3. Okay. So 0, 1, these two are taking the inputs. These two are inputs taking the information from the B naught. Or suppose this is the B naught, B naught, B naught. If it is 0, directly we have to connect. So the 0 input directly we have connect. If it is 0, I need to make that 0 into 1. Again we have to take you know that 1. What is the symbol? What is the symbol?
Not gate.
Not gate. If it is 0, if it is directly connected, you will get 0. Okay. If it is 0, if you want to get 1, so the 0 is in input is acting as a, acting to the not gate. This is converted to 1. It generates 1. This is about B naught. Like that. Next one, B1. B1, if it is 0, you know that directly connected. So if it is 1, 1. Okay. Similarly, we have to do for this B1, B3, and so B2. What about B2? So directly connected, not gate 1. So next B3, B3. This is directly connected to 1. This is directly connected to 0. If you want to perform this one, G1, next one. Okay. Next, 0, 1 are selected. What about remaining? Already 1, 0, so starting 1, 0 is selection lines. Again, 4 inputs are there, 0, 1, 2, 3. By selecting B naught, B values, we can select 0 and 1. If it is 0, normal simple 0 is selected. If it is 1, we are complementing 0, then we can get 1. Okay. This is about how to select 0, 1 in all the multiplexers. And one more thing is that again 2, 3, these two are there. 2, 3, these two are there. So these two are, so extra we are taking one more. We are taking, this is 0. Okay, 0 gate, which is called as 0 gate. If you take 0, if you take 0, 0, I'll explain clearly. Later, I need to draw this one. 2 bit is selected. Next, next second line. So 2, next one, 2. Okay, okay, next to 2. If it is 3, after complement all these things, we have to select 3 and 3 and 3, directly 3. So these connections are all these connections are over. Now why not? This why not is taking the input from the multiplexer. Y naught is taking the input from the multiplexer. This y1 is taking the input from the multiplexer. This y2 is taking the input from the multiplexer. This one is y3. This one is y3. So this is the diagram for 4-bit arithmetic circuit. 4-bit arithmetic circuit. Now, what is the explanation include here is that I'll explain with the help of a new diagram. Are you getting this diagram? Hello?
Yes, sir.
Okay. Are you listening or sleeping? All are okay?
Listening,
Listening,
sir.
sir.
Okay. So this is see here. Don't forget this one, micro operation. Okay. So this is 4-bit. This is 4-1 already. What we have drawn already. This is so y not. Okay. All these are connections. If you see here, this is 0 gate. This is connected to all 2 inputs to the multiplexer. This is the after complement this one, or this one is connected to all threes. Okay. Next selection lines are there, 1 and 0. These two are connected to all 1 zeros of multiplexers. And so how to select this 0 1 input, 0 1 input by selecting b B1, B0, B1, B2, B3. So if it is 0, directly connected. If it is 1, we have to complement this one. So that we are using this not gate. Okay. Again this one complement this one, right? So next, how to select a naught. Directly we'll give the input to the full adder a naught, x naught, a1, x1, a2, x2, a3, x3, like that. How to select 2 3 0 gate we are taking. So all zero inputs given to the 2. And next, after complement, all these are connected to 3. Okay, this is about description of the so multiplex. Now, how it is working? How it is working? Here we have four adders because the size of the input is 4 bits. Size of the input is 4 bits, right? So here the advantage of the 4-bit adder is it performs addition operation on 3 bits. Performs addition operation on 3 bits. 4-bit full adder means it performs the addition operation on 3 bits. So how? X naught plus y naught plus c naught. Here x1 plus y1 plus c1, x2 plus y2 plus c2. It performs the addition operation on 3 bits. We are taking 3 inputs, so we are applying addition on these 3 inputs. Similarly, we have to use x3, y3, c3. Okay. So next, here the input to the x, x0, x1, x2, x3. So I am talking neutrally. So all these are terms of the x, so that the input to the x, right, from the first binary number, capital A. So we are talking a0, a1, a2, a3. I am talking neutrally capital A. All these are products of A, so that tracking. The input to the x0 is received from the binary number capital A. So here x0 and a0 receives inputs from the information. It receives information from a0. The same way x1 is receives information from a1, receives information from a2, receives information from a3. Okay. So this is first input. Here next, the second input to the full adder, this is the second input, will comes from multiplexer. This is the multiplexer. Okay, right? The output of the that is y naught. Okay, the output of the multiplexer is, this is the output of the multiplexer is acting as an input to the full adder, right? Right. Here these two are two inputs. Okay, next one more thing is C in is there. The carry value is passed to the, this is the carry value passed to the input C naught. Okay, three inputs are over, X naught, Y naught, C naught, three inputs are over. If addition perform, if the addition perform, result is stored, it's like a sum. The result is stored in T naught, and the carry is forward to the full adder. Carry is forward to the full adder. Okay, carries forward to the full adder. I am not connecting this one. If you cannot, okay, problem, no problem. Okay, carries forward to the, again the second adder having two inputs, addition of these three and forward to this one, and sum it gives, right? So right, so next, by seeing this, the scene is one carry input extra, so it performs the addition operation. It gives d naught and carry is forward to the next full adder. Here we have four multiplexer. By selection input, we are taking two selection inputs, so S0 and S1. We can perform arithmetic micro operations. Okay, if you take two, if you take two selection inputs, we can take 2 power n inputs, which means that if it is 2, 2 square, 4 inputs are there, it generates one output. It generates one output. That is the meaning of 4 cross 1. 4 cross 1. Here, the four the four inputs are there. The multiplexer output receives data from the multiplexer. Four, what is that? Four inputs are there. Each multiplexers, so 1 0 1 2 3, each multiplexers zero input, here the zero, this zero input receives from b naught. This zero input receives from b1. Don't concentrate on selection line 0. We have two inputs, 0 1 2 3 are there. If zero input receives from b1, this zero input receives from b2, etc. Okay, each multiplexer here, one input, this one input is receives from complement of b1, complement of b1. How, who is selecting 1? So if you give 0, it is 1, so that it represents 1. If it is 0, complement is 1, represent the multiplexer input, one input is receives data from the complement of b, complement of b, right? Next, here the input 2, the input 2 to to all twos, all the multiplexers, the input, each multiplexer input is 2, receives the data from the 0 gate. Okay, if you complement 0, we will get 1, so that 1 is passed to the all inputs of the multiplexer, all inputs of the multiplexer, so 3, 3, right? Right, so this is about a clear explanation of this process of what is the process going on inside this multiplexer. Each multiplexer having 4 bits, okay, four bits. Here, if you take 4 bits, 4 bits, if you take 4 bits inputs, what are the inputs? 0 1 2 3 4 inputs are there. 0 inputs receives data. It receives, what it receives data from which register? Register, register b. This one, this is the complement. Okay, it receives the data from complement of b, complement of b. This one 2, it receives data from logic gate 0, right? So 0 1 2, there is no 4, right? Only 3, right? Receives data from logic gate, you know that logic gate 1. Okay, This is about all the inputs of different inputs in the selection lines. Not selection lines, different types of inputs selecting from the lines, right? Now, if you observe, so one table. So see here. So what is the table? This is the table 4-bit arithmetic circuit table. S1, S0, C in, all these are attributes. What is the operation? What are the names of the operation? If the selection lines are 0, 0, the selection lines are 0, 0, the input is 0, the input is 0. Okay. So the y is, what is y? B. Okay. The what is the final sum? D equal to a plus b. So how it is? How it is? See, selection lines are, see here, d equal to what is a? A already we are taking 0. We are giving input a plus. So what is the input b? B we are giving. So y means what? So why we are taking where is that one? What is the formula? What is the formula? So here d equal to y
A plus Y plus N. 1.
a a plus y plus
1.
c. This is the this is
Seen.
c
Seen.
c in. Okay. So here if you give s1 s not 0 0, c in is 0, c in already 0. The y is selecting the data from b. We know that we are giving. So 0, if it is 0, if it is 0 0, if it is 0 0, okay, so we can select d equal to a plus, what is y, what is y, b plus 0 means d equal to a plus b, right? So if you give 0 0, so if you take one more. For suppose draw this table S1, S2, what S0, C in, okay, input. This input is Y. Okay. Output, what is output? D equal to A plus Y plus C in. A plus Y plus C in. So what is binary? It is C 0 0 0 0. This is one combination. 0 1 0 1 1 0 1 0. These two zeros are combination with the carry is 0 and 1. These two are combination with the carry is 0, 1. These two are combination with carry is 0, 1. Next, one more combination 1 1 1 1. These two are combinations with, so 0, carry is 0, 1. Okay. So here, so see 0 0, input is 0. So explain this one. Selection lines are 0 0 0 0. Okay. What is input? What is input? Input. What is C in? 0. Already C in directly we have given. No problem. Direct C in is directly 0. Selection lines are 0 0. Okay. If you give 0 0, so how to receive the data? So B not selected. B not. If you give 0 here, 0 selected. So the 0 is sent to the information. Y naught is taking the information from the B, so that Y equal to A. This is the input, first input B. So that we are uh, we are drawing like this. So here the input, if you give all the zeros, B will be selected. B will be selected. What is the output? D equal to already A plus what is Y? B. So if you see in is 0, no need to write here. Okay, this is about first one addition. By seeing this example, it equal to A plus B means addition micro operation. Okay, again we are giving 0 0. Again we are giving 0 0. So if you observe 0 0, this is very very important. Again we are sending 0 0 to this multiplexer. Okay, so what is the scene? What is the scene? 1 1 we are taking. Scene we are taking 1. Carry is 1. Carry is 1 means so here how to write this one? We are sending 0 0. Okay, so carry is 1. Again B, D equal to how to select A plus B plus. Okay, if it is 0, we are not placing here 0 so that A plus B. If it is 1, these two input selection lines are 0 0. D equal to A plus B plus 1. A plus B plus 1. Right? Next 0 1 0 1 0 1 0 1. So what is happening inside this? So 0 1 and 0 1. If you give selection lines 0 1 0 1, selection lines means S0 and S1. Remember S0 and S1. The first if you give 0 1, if you give 0 1, C in is 0. 0 1 means we have to select see here 0 0 1. Okay, these two are 0 1. Scene output scene is carry is 1. Okay, carry is 1, right? So if it is 1, I need to select so 1 from here. How to get 1? By the complement of b naught, by the complement of b naught. So what is input? How it becomes? So what is the input? What is input? What is input? So here if you give 0 1, see in carry input is 0. Okay, this is it becomes a b complement. 0 1 means so if you give 0 1, it will select 1. It will select 1. So how 1 is coming? How 1 is coming? By selecting the input. By selecting the input. Did you understand this one? So 0 1 selection lines. So 0 1 we are passing here. How to select 0 1? 0 1 means it represents 1. This one how to select? How it is coming 1? Hello? Can you tell me? The one this one information is received from where?
B bar, sir.
What is that? B bar means what? Complement of
Complement.
complement. Yes or no? So for suppose if it is these two are 0 0, 0 will be selected so that we have to take B. Okay, so if you apply 0 1 selection lines, the one is selected here, the one input is received from where? B naught. If it is 0, the complement is 1. Like that we have to understand. Did you understand? Hello,
Yes, sir.
did you understand? Okay, okay. So that this input is selected to the multiplexer is B bar. Okay, so B bar, right? So again, so how to write this one? D equal to, already we know that A plus, so what is Y? B bar. What is C in? C in 0 is there, no need to write here 0, right? Again 0 1, again 0 1. 0 1 already we know that 1 will be selected. Okay, how to get this one? So this is the this is the carry input. We know that if you give 0 1, how to the input of the 1 multiplexer will be selected, the input of the 1 will be selected. How to receive that input? That 1 is received from complement B, so that B bar D equal to A plus B bar plus What is C in 1? What is C in 1? Now, can you tell me what is this one? If you observe here, A plus B bar plus 1 means what? Can you tell me?
Subtraction.
Subtraction.
Yeah,
Yes.
yeah, yeah. Very good, very good. Subtraction, subtraction. This is the meaning of subtraction. Okay. Next combination is 1 0 1 0 combination with 0 and 1. 1 0 1 0 combination with 0 1. 1 0 means what? If you select the selection lines 1 0, it will select 1 0 means what is the decimal number? What is the decimal number?
2.
2
2.
will be selected. 2 will be selected. Okay. If it is 2, 2 will be selected. So this will be carry 0. First time carry 0, next time we will change the carry 1, right? So here 1 0 1 0 2 will be selected. So how to select this one, 2 2
From logic
by
gate.
from logic gate, 0 logic gate, from we what we are passing to the logic gate, by passing what we are passing to select two all twos of the multiplexer from the logic gate. What we are passing here, see,
0.
0 we are passing, 0 we are passing, so that the input is the 0 input is taking from the logic gate, the multiplexer, the 0 input is taking, right, it sends to the fully adder, right? So here input is 0, input is 0, so that d equal to, okay, a plus what is y value 0, what is c in value 0, so that a equal to d equal to a, d equal to a. Next 1 0 1 0, next c in is 1, right? Can you tell me this one, 1 0 1, if you apply 1 0, if you apply selection lines 1 0, I'm sure 2 will be selected. So how to by selecting which gate, 0 gate we are selecting, okay? So what is the input? The 2, the 2 number is there inside this multiplexer. The 2 is received the input from where? Okay, 0 gate. So that 0, right? So 0, what is this one? D equal to a. How to select this one? A. What is next one? What is next one? What is the B? Chapandi, what is this? So B B means input is 0, C in is 1, A plus 1. This is the increment. If you observe here, addition is there. Next, complement is there. 2's complement with normal register. If we add these two, we can get so subtractor. So this is the increment. Okay, like that we are performing different types of operations. 1 1 0. So 1 1 1 is there. If we get so like that we can perform 1 1 1 1 means 3. 1 1 means, so selection input is 3, carry is 0. So can you tell me what is the input? Can you tell me what is the input? So by selecting which number, by selecting which number we are getting 3, 3
Complement of 0 logic gate.
complement of 0 logic gate, right, right. So complement of already we have given 0. So this is the input is passing 1 to the all threes, so that we have to write here. This is also 1 1 1 1, so that 1 1 we are writing. Again we are writing here the one mistake. So even though this is like this, actually by d equal to what is this one? Already a is there. Next a input is 1, input 0, carry 0, so input is 1 plus 1. But here if you see here, 1101, we can get d equal to a minus 1. How it is, I'll explain tomorrow. Okay, so d equal to a minus 1. Okay, we are getting d equal to a plus 1, but by applying the circuit we will get like this. We'll explain tomorrow how it is d equal to a minus 1. The next one is 1 1 1 1. So what is this, how to give this one? Sin is 1, a sin is 1, and c next one d equal to, we can get a. How these two are d equal to a minus 1, d equal to a, you'll explain tomorrow class. These two are different. Okay, you'll explain tomorrow class. Did you understand all these things? So by using selection lines, all these things, 0 0 0 0. Okay, did you understand clearly?
Yes, sir.
Okay. Okay, 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 very good. If you do not understand, no problem. By seeing material, we can understand easily. So, so end of this, can you understand little bit? Can you understand this one by this explanation of this diagram and input? Okay. If you do
Yes,
not
sir.
Yes, sir.
understand, okay, 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 okay. If you do not understand, no problem. I'll explain tomorrow on more time. Okay, right. Okay, the time is 2:54. So thank you all. This is the today's class. We'll discuss tomorrow how it is, and a minus 1 and d equal to a. We'll discuss tomorrow. Okay. So
Okay,
thank
sir.
you all.
Thank you, sir.
Thank you. Thank you. Lal is there
Thank
inside
you
the
so much.
class.
Yes, sir.
Thank you, sir.
Okay, Amma. Thank you. Thank you. Thank you.